Hello, I want to make a quick video about a barebones ZMK keyboard. It's a great starting point for you to create your own custom keyboard with all the features of ZMK. First, you need to set up your ZMK config. For this, I already have a video you can look at. I already have my ZMK config created and I called it kbname. So it's easy to customize to what you want to call your keyboard. The files are available on my GitHub repository that I linked in the description of the video. Let's go over the bare minimum you will need for the firmware build to succeed. First, we'll look at our build.yaml file. Here we mention which boards or shields need to be built by the GitHub actions. In this example, we use a nice nano v2 and we called our keyboard name. Next, we'll go over the devicetree files that are going to describe our keyboard. These will be located in the directory /boards/shields and then a folder with your keyboard name. The first two files we will look at in here are kconfig.devconfig and kconfig.shield. In the kconfig.shield, we define a new kconfig symbol named kbname. And we declare the symbol as a boolean by using the macro provided by ZMK, together with the name we want to give our keyboard. In the kconfig.devconfig file, we use the kconfig symbol we just created and set a keyboard name. This is done by giving a default value to the ZMK keyboard name symbol. In our case, it's keyboard name. This name can't be longer than 16 characters, and this is due to some Bluetooth limitations. That's everything for the config files. Next, we go over two different devicetree files, kbname.keymap and kbname.overlay. These files need to have the same name as the shield name you chose. Note, the Bluetooth name we defined in kconfig.devconfig can be different from this shield name. The physical components of the device tree are described in the overlay file. This includes which pins are used and how the firmware scans for activity on these pins. The keymap is described in the keymap file. Technically, these could be combined into one file, but I prefer to split them up. Let's check out the overlay file. In the overlay file, we have to define a couple of nodes. The kscan node. Here we define which pins are used and how we did the wiring for our matrix. The wiring is the diode direction. It can be either column to row or row to column. Here you can also see the column GPIO pins and the row GPIO pins that are being scanned. Next is a default transform or a matrix transform node. This defines the matrix of our keyboard. In this example, we have 4 columns and 2 rows, where only 5 keys are mapped. Next is the physical layout node. This is a mandatory node, and it selects which transform is being used by the keyboard. And then lastly, we have a chosen node, where we choose which kscan or which physical layout we want to choose. Later on, we can get more adventurous and define multiple physical layouts for a board. If you have any questions about the different nodes, you can always drop a comment. Let's check out our keymap. In our keymap, we have one node. It's a keymap node. In our keymap node, we have one layer. In the layer, we have a bindings tag, which is filled with a list of key presses. So anytime our key matrix notices we are pressing a key, one of these keys is being pressed. In our case, it's a letter O, A, E, T, or space. For a full list of the key codes that you can use in your keymap file, you should check out the ZMK documentation where everything is defined very well with a description of which platforms support which key codes. These are all the files you need for a barebones ZMK config. Later we will use this basic firmware to try out the cooler features of ZMK. If you want to see more of me, check out my socials on lander03xd.com.